Welcome to Do the Math America. Today we look at divisibility tests from the beginning algebra book, pages 45 and 46. Please look for the link below this video for a PDF file of this textbook. Divisibility tests. A whole number is divisible, the remainder is 0, by each of its factors. To find the factors of a number, sometimes it is helpful to test the divisibility by inspecting the patterns of the digits without actually dividing. You can see there are divisibility tests for the numbers 2, 3, 4, 5, 6, 8, 9, 10, and 11. I suggest you only focus on the divisibility tests for the numbers 2, 3, 5, and 10. While it's nice to know there are divisibility tests for those other numbers, it won't benefit you that much to have to memorize all those tests. A whole number is divisible by 2 if its last digit is 0, 2, 4, 6, or 8. In other words, if it is an even number. A whole number is divisible by 3 if the sum of its digits is divisible by 3. A whole number is divisible by 5 if its last digit is 0 or 5. And a whole number is divisible by 10 if its last digit is 0. Test each number for divisibility by 2, 3, 5, or 10. We look at the number 105. Is it divisible by 2? Well, since it is an odd number, it is not divisible by 2. Those three dots in a triangle shape mean therefore. So therefore it is not divisible by 2. Next, is 105 divisible by 3? Well, the digits 1 plus 0 plus 5 equals 6, and 6 is divisible by 3. Therefore, 105 is divisible by 3. Is 105 divisible by 5? Well, since 105, the last digit is 5, therefore it is divisible by 5. Is 105 divisible by 10? The last digit of 105 is not 0, therefore 105 is not divisible by 10. Next, we will test 1,248 to see if it's divisible by 2. And since it is an even number, 1,248 is divisible by 2. To see if 1,248 is divisible by 3, we add up its digits, 1 plus 2 plus 4 plus 8, which equals 15. 15 is divisible by 3 because 15 divided by 3 equals 5. Therefore, 1,248 is divisible by 3. Now we test to see if it is divisible by 5. 1,248, the last digit does not end in 5 or 0. Therefore, it is not divisible by 5. To test if 1,248 is divisible by 10, we look at the last digit, and since it is not 0, therefore 1,248 is not divisible by 10. Is the number 9,170 divisible by 2? And since it is an even number, it is divisible by 2. To test if 9,170 is divisible by 3, we add up its digits, 9 plus 1 plus 7 plus 0, which equals 17. Because 17 divided by 3 equals 5 with a remainder of 2. Therefore, 9,170 is not divisible by 3. To test if 9,170 is divisible by 5, we look at its last digit. If it is a 5 or a 0, it is divisible by 5. And in this case, 9,170 ends in 0, therefore it is divisible by 5. To test if a number is divisible by 10, if the last digit of that number ends in a 0, it is divisible by 10. And in this case, 9,170 does end in 0, therefore it is divisible by 10. We examine the number 78,903. Is it divisible by 2? Since it is an odd number, it is not divisible by 2. To see if 78,903 is divisible by 3, we add up its digits. And if the sum of its digits is divisible by 3, then it is divisible by 3. In this case, 7 plus 8 plus 9 plus 0 plus 3 equals 27. 27 is divisible by 3 because 27 divided by 3 equals 9. Therefore, 78,903 is divisible by 3. And now we test if 78,903 is divisible by 5. And since its last digit is not 5 or 0, it is not divisible by 5. Is 78,903 divisible by 10? We look at the last digit. If it is not 0, it is not divisible by 10. And in this case, 78,903 does not end in a 0, therefore it is not divisible by 10. We look at the problem sets for this exercise. I would suggest you only do the tests for divisibility by 2, 3, 5, and 10. So that would be problems 1 through 14, 22 through 28, and 50 through 56. Check your answers with the answers in the back of the book to reassure yourself that you have a good grasp of divisibility tests.